Having great time here. Sorry for the delay. So let's get started so that we can have real conversation in happy hours. Okay. Oops. Okay, so my name is Gautam Singh, and I'm a solution architect at a company called Mastech. They are based out of Dallas. And they work in e-commerce space, mostly retailers. And my specialization is in solution architecting, application modernization. And this year, in the beginning, I was working with one of retailer in North America, and I was asked to look at DynamoDB provision capacity mode and see if that can be used to save cost. And again, the whole idea was to save cost and see if it's something that can be used. And they had pretty old TP type of application, the consistent traffic. So we thought that it's going to be easy to enable provision capacity. And again, some statistics. They had multiple tables. Some tables containing in excess of 1 billion items, 1 terabyte in size, and over 10K items added every day. Used by multiple microservices serving million plus users. And this is the kind of a simplified architecture of the whole system. So there were multiple producers. These are different order sources. And then they basically publish message in Kafka topic. And basically then there are different consumers that consume the messages from these topics and store it in DynamoDB. And then we had different microservices accessing this DynamoDB and publishing APIs, which then is used by the front end. And we had, again, like ideally you should have one database per microservices, but we had like multiple microservices using same databases, sometimes using GSI, but other times, just having the same database. So before I continue further on my journey and the experience and learning, I would like to cover some basics for those who have not worked with DynamoDB or have not had experience in capacity modes. So there are different capacity mode within DynamoDB, with on-demand and provision capacity mode. And the unit of measure for both is basically read request unit or read capacity unit, and write request unit or write capacity unit. So one read request unit or read capacity unit. Again, read request unit is basically for on demand. When you request a unit, it will be granted to you. And the capacity unit is basically for provision, where you have actually provisioned that capacity. You may not actually request it, but that capacity is always made available to you. So for RRU or RCU, one strong consistent read up to 4 KB is equivalent to 1 RRU, and 2 eventual consistency read up to 4 KB. So if you are reading more than 4 KB size item, basically your capacity will be more. So for instance, if you're reading a strong consistent 10 KB item, you will be consuming 3 RRU. Similarly, for transactional read, if you are reading up to 4 KB, it's 2 RRU or RCU. And similarly for WRU or WCU, it's 1 write for an item up to 1 KB. And 2 WRU for transactional write up to 1 KB. And feel free to ask any question in between. On-demand capacity mode is one pricing model where you pay for what you are using. So when you request or read or write to DynamoDB, basically your RRU or WRU is going to be calculated, and you'll be paying what you are using. You only pay for what you use, so you don't have to plan for any capacity or anything. It's just pay per use. And it is capable of serving thousands of requests per second. It's like highly scalable, available. It guarantees single-digit millisecond SLA, and again, no capacity planning needed. So what's like, it looks like we have everything, right? So why we need another provision capacity mode? And the reason is because the way Amazon provide these guarantees is it always over provisions. And that's why the cost of on-demand is always higher. So when you would use on-demand, it's typically good for unpredictable traffic. So if you have like maybe an external users coming at random time and start using your application, then it's probably not a good fit for then probably it's a not a good fit for provision mode and a good fit for on-demand mode. It's also for mission critical application. So if your application always demand a single-digit millisecond response time, for example, if it's a trading application, or some hospital equipment for which the response time, is mission critical, then you always, want to use on-demand. And again, on-demand, this is something that we learned through our experiences. On-demand is also a good fit if your organization doesn't have the DevOps maturity level to automate things. Because when you are using provision mode, you have to adjust, tweak, and sometimes you have to actually tweak while your users are accessing in production. So you have to have automation and DevOps maturity level pretty high. Provision capacity mode is basically opposite. So you are paying for what you have provisioned for. So you define your capacity, and you can say that I want these many RCU and these many WCU always available to me, and you'll be paying for that. It does require capacity planning. So you have to plan what your application is going to need. And that is something that gets better with auto scaling. So you can use auto scaling with provision mode. So you can say that, my minimum capacity limit is this, and my max is that, and my utilization ratio is this much. And so DynamoDB will try to basically scale up and down your WCU and RCU based on your usage. So if your utilization goes above your utilization percentage, then it will scale up. And if it goes below, like there is a threshold. So if you set it to like 80% and the usage goes down below 60%, that it will scale down. The predictable cost is a big benefit of provision capacity mode. With an on-demand mode, is easy to implement it, but it's easy also to forget about it and suddenly find out, many $1,000 bill for your small databases, especially if your schema design is not proper. I have seen customer actually paying for, because they were actually doing full table scans, and that is very bad things. When to use provision mode? Again, it's opposite. So when you have a predictable application traffic, and again, predictability is kind of a tricky thing. We burn our feet thinking that our application traffic was predictable and find out actually the scaling was not able to keep up. So again, it's something that you might have to try out to see if your traffic is predictable and the scaling that provision mode by default provide is able to keep up. And also you have to play with some numbers again. So you also want your utilization to also be high, right? You don't want your DynamoDB to over provision and set it to 50 when majority of time you are only consuming 10, right? So there is some trade-off, and we'll talk about that. Yeah, and so basically these are also workloads for which you can forecast, right? So it's not that DynamoDB, you cannot use provision mode if you have like seasonal load. For instance, during the customer that we work, they used to get almost 20% their sales during the whole holiday period, right? So from Black Friday to New Year, but yeah, as long as you know in advance, you can plan for it. And I talked about high utilization ratio. So yeah, you use, again, if you have predictable application traffic, you can always tweak this number to get a high utilization. And yeah, means throttling is again on demand, you can also get throttle. So in on demand, if your consumption double twice within 30 minutes, you will get throttle. But the good thing about on demand is it's always over provision. So when you create a table, it starts with 4,000, actually 2,000, but it can burst to double immediately. So you can actually have up to 4,000 WCU and up to 12,000 RCU, immediately after provisioning the table. So it's always over provision. That's why a lot of clients don't get throttling, and that's another kind of area that we found some issues. So we'll talk. And again, cost gain justify. So as I mentioned, when we are going to do provision, enable provision mode, we need to plan for the capacity, and we need to make sure we do some kind of automation. We have observability in place, monitoring and alerting. So those are overheads. So you need to also justify, if you are saving maybe $50 and you are spending a couple of weeks doing this, probably not a good thing. And opposite to on demand, it requires a high maturity level in terms of DevOps and automation. So how scaling works? This one, so when you create a table and you enable auto scaling, what happens is, again, the utilization matrix is sent over to Amazon CloudWatch. And as soon as you create the table, it also creates a set of alarms in CloudWatch. And these alarms are basically your utilization or consumption, basically based on consumption. So for instance, if your table is provisioned with 50 WCU, it will actually create an alarm stating that if your usage goes beyond that 50 WCU for a period of, let's say, 60 seconds over 5 data points, then this alarm will trigger. And what will happen is the application auto scaling is one of the listener to that alarm. So what will happen is the auto scaling will actually kick in and it will adjust the table provision capacity. So it will adjust it so that it will keep the capacity below the utilization ratio. So again, like, we can give an example where, let's say you have a utilization, current utilization at 100, and the provision capacity is 80, then it will adjust it to like 120. So let's look at auto scaling in action. I'll just speak louder. So for this, I've created a project. So there is this Terraform project which provisioned all the resources needed. So let's look at what we are provisioning here. So we are creating a table. You don't say anything about that. Oh, I think it's shared to Zoom. Is anyone from our organization? Yeah, I don't know. Oh, now it's showing here. Yes. This happens for So this is the Terraform project. So we are provisioning a DynamoDB table, and it's called sales transaction, and it is using provision mode. The minimum capacity is 5, maximum 20, and the target utilization for RCU and WCU is 80. And then we have a bunch of declared attribute, and then it also has a TSI, though it doesn't matter for this exercise. And then we have created a Lambda function that basically calls get input on the table, and you provide the item values in the table. So I'm going to run it. I have already run it for and then actually others. So we also have another project. This is the locus-based load testing library. So I ran it right before this presentation for 20 minutes, so we can actually see what happens. Let's go here, and let's first look at the table and see what is the current provision capacity for the table. Okay, so current write capacity unit is 42 and read capacity unit is 5. So that's what we were only testing the write. So that's why it's implemented. Now let's look at the, so when you create a table, with scaling on, auto scaling on, you also need to create this scalable target. So you are basically saying that this DynamoDB table is using auto scaling. So you'll see two targets, one for read capacity unit and other for write capacity unit. Again, we have the minimum and maximum capacity defined here. And then it also creates these CloudWatch alarm. I'm going to just look at one of the alarm. I feel free to ask any question. So this one, you can see that it's, again, these things are relevant. So the alarm action is what's important. So this alarm action is set to this auto scaling action. So when this alarm will be triggered, this auto scaling action will get removed. And so this one here, it says the statistics is sum, and the matrix name is consumed read capacity unit. And evaluation period is basically that's a data point. So it's going to go 60 seconds for 2 data points. And the total sum of the capacity unit should be 240, and the operation is greater. So whenever the total consumed capacity unit will be more than 250 for 60 seconds for 2 data points, then this alarm will trigger. And let's look at the scaling activity that had happened. The load test was going on. So again, when you create a table with provisioned capacity mode enabled and auto scaling enabled, in that case, whatever you define as a max capacity unit, it will actually provision your table initially with that. And then if it's going to see that the so yeah, so if you see here, it actually scaled down. So initially, it might have created the table with the max capacity, and then it scaled down here, and then it happens multiple times. So again, if the utilization is nothing, then it will again try to scale down. I think under the hood, it doesn't actually set the capacity unit. It's already set to whatever it's trying to set. So again, it will trigger, but it won't set the capacity unit because it's already set to 5. And then here you see the write capacity unit was increased to 20. And then I think the load might have more than 20, and then it got even increased to 41 and 42. We can also see that in our CloudWatch console. Here, let's look at the CloudWatch. Yeah, so here you see this is one of the problems that I was mentioning. So the red one is provision capacity, and the blue one is consumed. Oops, sorry. Okay, now I cannot enable both. guess there's a bug in console. So yeah, the red one is the provision capacity. So that's what is available to you. So initially it was set to 100, then it went down to 5, which was the minimum because there was no usage. And then we started the load test, and you can see that the consumed capacity actually increased more than this one, but the scaling didn't happen for maybe, I don't know, like maybe 5 minutes. So from 42 to 48, so 4 minutes, 6 minutes, it didn't happen. So that's what I was saying, sometimes again, like DynamoDB supports burst capacity for 5 minutes. So if you are running an application and you have a provision capacity of, let's say, 100, and for the last 5 minutes, you are only let's say you are not using anything, right? So what will happen is it will basically accumulate that 5-minute capacity that you have not consumed and give it as a burst. So you can burst into that capacity, and it will basically allow you. Again, you cannot have it like within 2 milliseconds. It will basically spread it out, but you can have that even above your capacity. So it doesn't mean that if the graph actually went up that your request was throttled. It could be that you might have actually got the request fulfilled by the burst capacity that was available to you. We can actually look at here in the alarm and see if there was throttling that happened. So you see these were the alarms that was triggered. And if we look at any of these alarms, so let's look at last one. Look at action, you'll see that the auto scaling action has fired. So again, these like all alarms were actually basically, if you see, all alarms had some action. So your provision capacity will get adjusted. And what we did actually for one of our tables, the requirement was the spike was actually too high, and we were not able to see the scaling happen, and there was throttling that was happening. So we actually created our own scaling for the table. So we disabled the auto scaling on the table, but then we created a lambda function which will basically and created alarms. And the alarms was actually, so this alarm is actually, you see 60 seconds for 2 data points or 4 data points. So we kind of reduced that to 10 seconds for 3 data points. So that way, we were able to scale fast, and we saw a consistent bell curve actually forming. So that was one customization that we did for our client. Any question with respect to this demo? Okay, let's back to slides. Okay, so let's talk about how we did it. So before even you begin, right, there are a lot of things that you need to see and evaluate. First thing is is it worth the hassle, right? So when you are going to when you're going to enable provision capacity, it's not going to be one click of a button, right? You have to do a bunch of additional things. So you have to weigh in the trade-off. So if you are paying $50 or $10 a month for a table, probably not a good idea to even think about it. Again, you have to understand the traffic pattern. So for one of this application, we actually look at the traffic pattern over several months, and we analyze it and see if these spikes that you see can be handled through the burst capacity that is available to us, and you have to go through that analysis. And for read, we actually saw it to be more spiky. Again, you have to understand, what is your traffic pattern, and make sure that your application traffic pattern fits with what provision capacity is going to offer. Again, you don't want to enable. We actually find out for one table we enable provision capacity more, but we found out we were actually paying more than on demand because we over provision as the traffic was not that consistent. We actually set the provision minimum to way higher than what average consumption was. So you need to watch for those anomalies. Again, cost analysis, I already talked about it. For one of the tables, we did this analysis. So we, look at the per minute WCU, RCU, WRU, RRU, and then we look at the cost. We calculated, again, we kind of make some calculation here. So we looked at the traffic pattern and identified that majority of the time we were actually seeing So yeah, here. So we were actually looking at it, and okay, I think this one doesn't have it. So yeah, we kind of calculated that what is our average WCU and RCU, and we also take a median and see what percentage of time it was actually going above our minimum or average, and then we calculated kind of projected utilize RRU and WRU, and we calculated it to be 37.8 per month. This was again obviously an not well utilized table, but even for this, we when we computed the provision capacity under the same condition, we say that we find out that we are actually saving more than 50%. So again, the capacity planning is a headache that nobody wants, especially if you are using managed services. But I can promise you, it's not that bad with DynamoDB. So you have to basically gather the historical data that you can easily get from CloudWatch. You can see traffic pattern. Calculate average read-write rates. You can also calculate peak read-write rates during the day, not seasonal peaks. Seasonal peaks we handle. We'll talk about later. And then we'll also talk about see if there are promotional peaks and seasonal peaks. And again, that's that's not a problem. Most access partition key. So now with adaptive capacity that you don't have to worry about partition as much. When you have a hot partition, DynamoDB will adapt and basically split that into multiple partitions. So you don't have to worry about partition so much, but you still have to worry about hotkey. So if you have maybe a customer that contributes to 20% of your website traffic, then it can still be a problem if your key is the customer ID. You have to again worry about indexes, right? So if you have multiple indexes, if you have for instance a table with 3G global secondary index, and you are doing a write on the table, it will also do a write on your global secondary indexes as well. So again, your writes can multiply based on how many indexes you're using. You have to watch for again queries that are resulting in scans. So again, that can also multiply your usage. Again, it's a problem even with on-demand, but on-demand this problem doesn't show up because just on-demand is poor provision. Acceptable error rates. Again, like, you have to understand what is your response times SLAs for a lot of our application. If we can still tolerate a little bit of throttling, but again, we have to make sure that those errors are handled by the application. And again, it's more evolutionary for DynamoDB, so you don't have to get it perfectly right. You can actually evolve as long as you have proper, monitoring and alerting in place. You can evolve. So, for example, this is actually one of the production table. We saw throttling. We had alerts enabled. We got alerts, and then we immediately deploy a change. And basically what we did is it was set to 80% utilization ratio, and we just set it to 70%. And you can see that the scaling is working perfectly here. So now, like, earlier, if you see, this one is like, the consumption goes up, but the scaling actually is, this is the blue one is the consumption. So this is up, but the scaling is actually kind of catching up. And in here, you can see, as soon as the consumption is rising, the scaling is going up here, and here also you see it's going up. So it's like, just by lowering the utilization by 30%, we were able to make it perform better. Again, like, there is a trade-off here. So when you lower your utilization percent, you are also lowering the your utilization ratio, right? So vice versa. When you are lowering the utilization ratio, you are also lowering the utilization percentage of your provision throughput, right? So you also have to weigh, again, like the cost benefit. And we also find out that we, a lot of our application were actually not handling the, provision exceeded exception. So when the throttling happens, you'll get like provision exceeded exception. And many of the application were not even handling it. So we had to make also some changes to different application. There were some application that didn't have any timeout setup. So, again, like, if you are being throttled, some of your requests may timeout, and you don't want your, your API to error out after like, 5 seconds or 10 seconds. You want to fail fast, right? So we have to make sure that the application had, proper timeout based on their SLAs setup. Again, monitoring and alerting is very important. With provisioning, even with Dynamo on-demand, it's important, but with provisioning, you have to have proper alerting in place. For example, for us, we set up kind of, this architecture where we set up different CloudWatch alarms, and they had a listener or subscriber SNS topic. And then once the alarm is triggered, it gets published to the SNS topic. And then we had a Lambda function, which was subscribing to this topic. And this Lambda function get triggered, and it sends a message to our ops channel, which is using MSTs. So again, like, and then parameter store is just used for like, credentials. So again, you've got to have some kind of, alerting in place to modify, the operations fast. Again, automation, like we used Terraform, Cloud Terraform to automate, and infrastructure as code. But again, it's your choice. You can use CloudFormation, serverless, framework, whatever is used in your organization. But having automation, like the one example I gave, and the table with throttle, we were able to just deploy, make the utilization ratio 70% and deploy it immediately and get it resolved. So without automation, those kind of things are impossible. optimization hacks, again, like one of the things I already told you, like, for one of the customer, we, kind of implemented auto scaling, like a custom scaling. Again, there were also, what we did was we also did a upfront planning for seasonal peaks. And what we did is we also use on-demand mode for non-prod environment. Jumbled up. So yeah, means for non-prod, our usage was very spiky, not spiky, but kind of only used when QA are testing it, or developers are doing some testing as well. So that's why having provision mode there doesn't make sense, because most of the time those environments are not even used. So we set it to the on-demand. We also had a scaling event set. So for our perf or performance test environment, we had basically a schedule. So basically, what you can do is you can also configure. Again, I'm using here AWS command, but you can do the same using Terraform or CloudFormation. So here I'm actually adding a schedule action, and it is going to be triggered. This is UTC time. So 5 a.m. in the morning, it will trigger every Monday to Friday, and it will set the minimum capacity to 1 because we know that at night nobody uses it. So again, you can do all kinds of optimization with provision mode. And you can also switch between, right? Like for the Thanksgiving time, we just enable on demand, because we just don't know how our traffic will be. It always increases year by year, and we don't want any impact on our business during that time. So we enable on-demand mode, and that you can do it once a day. So you can actually switch between the on-demand and provision mode once a day. So yeah, I'll end this talk with just a little story. So a group of Italian researchers actually went to Jamaica, and they looked at the soil, the weather, and they found out that the soil and weather is suited for growing vegetables, but nobody was growing it. So they had a eureka moment. They said, we are going to grow zucchini and tomatoes and all the vegetables. And so they gathered a team. They basically cultivated those, and the crop was turned out to be very good. And they were just marveling at their achievement. And the next night, some people came and they basically savaged the whole crop. So the moral of the story is, like, I've seen companies actually using the services and tools, sometimes not actually putting the due diligence to know the internals of the tool. And that's why I even recommend my clients to actually use provision capacity mode first, though AWS actually recommends opposite. The reason why I do that is because when you enable provision capacity mode, you will actually get to know DynamoDB better. And if you know DynamoDB better, you can actually basically design your application better. So that is my again take on using provision capacity mode. Thank you. Any questions?
So you were saying from the holidays time, you guys jump between provision or something.